Finding the greatest common factor, also known as the GCF. Example 1. Find the GCF of 20 and 45. What we want is the largest number which divides evenly into both numbers. You might be able to figure this out in your head. It cannot be larger than your smallest one because it has to go into both. And so you might guess on this one that it's a 5. But we want a technique. So what we're going to do is break these numbers to primes. So for 20, we could break down to 4 times 5. And then we keep going. So 4 will give us 2 times 2. And 5 is already prime. For 45, we can do 9 times 5. And 9 will keep going. And 5 is already prime. Right? So we want the biggest thing that is common to both. Common means it has to be in both pieces. So we look at the 2's. We're not allowed to use a 2 because the second one, the factors of 45, there is no 2. Also, we can't use a 3 because the first one, the 20, has no 3 in it. So the thing that we see that is common to both is the 5. That is the biggest thing that is common to both 20 and 45. So our GCF is 5. Next, we'll find the GCF of some variable terms, x to the 4th and x to the 7th. For this first problem, we'll write them out. So if we write out x to the 4th, it's 4 copies of x. And x to the 7th would be 7 copies of x. And then we will pick the part that's the same. So we have x in each one. So we have this many x's in x to the 4th. And that's all we can take out of the other one because remember, they have to be common. So our x to the 4th is going to be our GCF. So for variables, what would you say about the GCF? As long as you have the same variable in each one, you will need to go with the lowest exponent so that it will be common. For our next example, find the GCF of 15x to the 6y cubed and 45xy cubed. So we'll do these with numbers and then each type of variable. For the numbers, one trick I always look at is see if the smallest number will divide evenly into the largest. And the 15 does go evenly into 45. So 15 is going to be our GCF for the number. I'm just going to go ahead and write that on the side, but then we'll verify it. And also from our last example, remember if the variable is in each one, you go with the lowest. So the x is in each one, we'll go with just one x. And the y is in each one. These are the same. So y cubed is actually common. Right, so 15xy cubed is actually our GCF, and we didn't really have to write out anything. Let's just verify it, though. So for the numbers, we'll break to primes. 15 is 3 times 5. And the variables, you can write them out. So we have 6 x's and 3 y's. 45. So we have 5 times 9. And our 9 gives us some 3's. And we have 1 x and 3 y's. So then we will pick the common parts. First of all, for the 3, we have a 3 here. And we have it in the other, so it is common. The most we can take is 1 because that's all your first term has. We have a 5. It is in both, so it is common. For our x's, we can only take one x because that's all that's in the second one. And for the y's, we have 3 in both. So the 3 times 5, we just multiply those back together. That gives our 15, 1 x from each one, and 3 y's for a y cubed. So 15 x y cubed is our GCF. Next, we'll find the GCF of 10x cubed, 20x squared y, and 40x to the 4th y squared. First, for the numbers, let's try and see if the smallest one divides evenly into all. So 10 does divide evenly into 20. 10 also divides evenly into 40. So our GCF number part is going to be 10. Then for the variables, let's check. Is x in every term? It is. You have to go with the one with the lowest exponent. So x squared is all that's common. And then for the y's, to be a little careful, the first term has no y. So y is not common. It is not part of the GCF. We can verify that GCF by looking at the breakdown of our primes. So first of all, for 2's, we do have 2 in every one, and it has to be common. So we can only take 1 2. For 5's, we do have 5 in each piece. So we can only take a 5, and this is the 2 that we took. So we can take a 5 from each one. That part is common. And that's all of our numbers from this one. Then we look for the x's. So it has to be common. This one has 3, this one only has 2, and this one has 4. So it has to be from this one to be the common part. So you can take 2 out of each one. And then your y's. You're not able to do a y because there is no y in the first term. And then we just multiply our 2 and 5 back together to give 10. So our 10x squared is the GCF.